Okay, so on this one, we are dealing with a lawnmower. A person pushes a lawnmower with a force of 21 pounds. The handle of the lawnmower is 62 degrees above the horizontal. How much downward force is being exerted on the ground and how much horizontal force is being exerted? So let me try my best to draw this. Not required, but might be helpful. So we got a lawnmower. I'm not very good at drawing lawnmowers. So I'm just gonna, go. Couple lawnmower tires. I'm just gonna go lawnmower. Looks like a baby carriage, looks like a truck or something. I don't know. Whatever. So I'm just gonna make it straight. There it is. There's my lawnmower. It's best I can do in short time. All right. That is the handle. Now, notice they say it makes an angle of 62 degrees above the horizontal. So let's put in the horizontal. And that this angle is 62 degrees. That's what they're saying. Okay, so, and then the person, I'm gonna draw a big, giant purple person here. Okay, it's a little too big. It's still too big, I think. That's fine. No. They are pushing on the lawnmower. They are so happy to be mowing the lawn. They're pushing on the lawnmower. Now they're pushing on the handle, and it makes a force that goes down the handle, down that direction. The force is 21 pounds down that handle. Now you might say, what if they're pushing a little bit sideways, Mr. Heron? It doesn't really matter. However they're pushing, in the end, the force has got to go down the handle. Down the handle. So the force is down the handle. So if that's the case, how much of it is downward force and how much of it is horizontal force? What we're talking about, in other words, is the fact that it actually has a down push to it. Right? Let me do a better job of that. It does a downward push, and it does a sideways push, doesn't it? So this is the down force, and this is the horizontal force. So this is what they do all the time in engineering, physics, is that you'll have like a diagonal force on something, and they'll ask you how much of that diagonal force is downward push and how much of it is sideways push. In other words, we want to break it into this is the y and this is the x components. Oh, well, we know how to do that, right? We know about the components if we go to our notes. Here it is right here. X is m cos theta, y is m sine theta. That's how you get the component form of a vector. So let's use that. So in other words, downward, that's the y. So the y, that's going to be m sine theta. M is the magnitude, which is the 21, the force, the magnitude of the force, times the sine of the angle, which is 62 degrees. So hit the buttons on your calculator. I'm getting 18.54. So they're pushing down with 18.54 pounds of force. By the way, we can, well, let's first do the, before I do any by the ways, let's first finish up getting the horizontal. The horizontal is the x. That's going to be m cos theta, which will be 21 cosine 62 degrees, which comes out 9.86. So the sideways is 9.86. All right. Now, do you notice, by the way, if we did SOHCAHTOA triangles, because we do have a right triangle here, we get the same answer. I just want to prove to you that what we did is really the truth. It's what it fits with what we know about triangles. But what do I mean? If you took, for example, the sine of 62 degrees, right? Opposite, this is opposite. This is hypotenuse, this is adjacent. Right, sine of 62 would be opposite would be y over the hypotenuse, which is the 21. It's opposite over hypotenuse, right? So katoa, sine, you remember. So katoa, I'm just proving to you these formulas are right. Sine is opposite over hypotenuse. And then what would you do from there? Well, then you would need to put this over 1 and go cross multiply and see what you would get. We'd get 21 sine 62 degrees is 1 times y. In other words, y equals 21 sine 62. See, it's the same thing. I just want to again prove to you those formulas, that m sine theta for y and m cosine theta for x, they're because of SOHCAHTOA. So anyway, we got it. So we got the first part of it anyway. We got the downward push and the sideways push. So basically a 21-pound force at an angle of 62 degrees with the horizontal produces a downward force of 18.54 and a sideways force of 9.86. So then the question is, which is, now notice it says all that apply. There's going to be more than one. What's their next question? How do these forces change if the handle is closer to the horizontal? Okay, so now what if this handle is moved down? Like, say there. Let me back it up and try again. Like right there. Stretch out a little bit longer. What if the handle's right there? Right there. I keep doing that. All right. Anyway, what would the person do? Well, the person, poor person, would have to, oops. Let me try drawing the person again. Person would have to bend down. Oop, their head just got small. And push like that, wouldn't they? I don't think they're going to be very happy anymore. Kind of sad. They'd have to push. Their back is bent over. They're going to have to push more sideways. So what if the handle was lowered down like that? Right? See how that handle came down lower? Everybody seeing that? So if that handle came down lower, the handle's closer to horizontal, and they're still pushing with the same 21 pounds of force, what's going to happen? Well, it's going to have more of a sideways effect, right? The horizontal force will increase and the downward force will decrease, won't it? If the person stoops over like that and pushes with the same 21 pounds of force on a handle that's lower, closer to the horizontal, that's going to produce more of a sideways force and less of a downward force. And their final question, if we want more of the force on the handle to move the lawn more forward, so if we want more to move the lawn more down the road, you want to lower the handle closer to horizontal. I forget exactly what the words are they have there, the different options, but that's basically it. If you want the lawnmower to have, right, if we want more of the force on the handle to move the lawnmower forward, to move it, sideways instead of downward force, because the downward force is kind of wasted, isn't it? Right? You're not going to accomplish anything by pushing down on the lawnmower. It's only the sideways force that matters. And so if you lowered the handle closer to horizontal, then more of the force would go sideways, which moves the lawnmower forward, closer to horizontal. So there we go.